All right, so we are back in class number 2, exercise 7 this time. Class 2, exercise 7. And this is about Linux file permissions. And there's two components to think about when you're thinking about file permissions. One is the actual file permissions, like what are they? This RW, this part of it, the yellow part, the read, write, execute, read, write, execute, read, write, execute. And then the actual users and groups who it belongs to. So uh, the first part of it tells you that ignore the first dash because that's special if it's a directory or something else. But this one tells you read, write, execute, and this one is read, write, execute. So you have the first triplet, if you will, read, write, execute, applies to the owner of the file, which is the first name here. The second triplet, read, write, execute, applies to the group. This is the name of a group here, the root group, the root user and the root group. So the root user and then the root group. And then the third one applies to anybody else on the system. So that's world or whoever else is in the system. So user, group, world, permissions. User, group name. So if you have those, if you have this user, this applies to you. If you're part of this group, then this applies to you. If you're anybody else on the system and you're not either this user or part of this group, then this applies to you and what privileges you get. And there's three things you can do with any file. You can read it, you can write it, or you can execute it. Read, write, execute, read, write, execute. In the case of directories, directories are also considered files. Read means you can see it. Execute means you can go inside of it. And so let's look at a few here. And so this I already described, the three triplets. And so if you look here on the right-hand side, I'm going to clear this, ls minus laf, la capital F. I just like it better that way because it shows all the hidden files too, like the dot and the dot dot. But you will see that a lot of these files, they should belong to root, but I changed my files to belong to Kali. So a lot of them belong to Kali. Most of them belong to Kali. Here's an old file that I guess never got changed that is slightly different. So Kali can read, write, and execute. Whoever's in the group Kali can read and execute, and the whole world can read and execute, which is probably not a good idea. And that's something I will want to change right away on that file because I don't want everybody to copy the files from here, perhaps anybody else on the system. And perhaps I don't even want people to be able to read the files in this particular directory. So I'm going to look at, I'm going to change. Chmod means change, change mod. I don't even know what that stands for, but it basically says change the permissions. Basically, that's the command on Linux to chmod to do that. So it's going to say chmod 600. So if I do first, let's look at that ls minus laf web app.php, and then we're going to do chmod 600 on web app.php, and then we're going to look at what the permissions are. So beforehand they will read write as well as read read. So anybody in the group Kali could read, and anybody in the on this computer on this Kali server can read it. So but now afterwards only the actual Kali owner, the Kali user, and the owner of the file can read and write it, because the rest have been denied, have been taken away those rights. Now you're wondering what is 6600? I mean, it's obvious if I say 0 and 0, that means you're going to erase any permissions, right? So that's pretty straightforward. That's why these three, and that's why these three are the last two triplets, right? The world triplet here and the group triplet have been set to 0 because I said 0. So 600, the 0 and the 0 apply, each number applies to a triplet. But 6, how did I get to 6? How does 6 equal to RW dash or RW nothing? And that is basically, for the simplest terms, this is using bits like 1 and 0. So if R is a 1, then it sets the R to be on. If W is on, it sets it to W to be on. And if this is 0, then the bit is 0. So it's basically 110, and 110 in binary is 6. I will show you in a minute. So that's how 6 binary is 110, and that's how we get on, off. So that's how we get RW. That's how we get this triplet to be RW nothing. All right. So let's try to make a file. We can make it on the desktop. You can make it anywhere you want. We can make a okay, so I'm just going to do it. You can use your editor file, but I'm going to do it the old-fashioned way here, called touch test.txt. Touch basically just says make this file, and ls minus laf text, and so that file comes out as read write read by default, right? Now if I chmod at 600, what do you think is going to look like? Chmod 600 test dot, its guess is going to be what? Nothing on the world, nothing on the group, and only read and write 110 on the yeah, so again, nothing on the world, nothing on the group, and only read right here. It's the same thing as we did above. All right, so we can also try it 400. If we do chmod 400 test, this is going to do what? It's going to be 4 in binary is 100. In binary, 100 is the same thing as 4. So let's see. So that means we took away the right, because it's 1, 1, 0, 0, 1, 0, 0. That is equal to, from binary to decimal, that translates into 4. And so we took away the right permission. All right. Let me give you a quick, so here if you look on the left-hand side, I did a bit of a math. You can think of each one of these triplets. So here's one way to think of the triplets, just to make this math easier, because it's either 7, 4, 5, 6, you name it. In fact, let's make 6 here, right? So if we say 1, 1, 0, that equals to the first position. The first position is equal to 4. So that's going to be 4 plus the second position is always 2. So that's 4 plus 2. And the third position is 0 or nothing. So that's where we're going to make that blank. And so we're just going to equal. So 4 plus 2 equals 6. So that's how we get to turn on the first and the second position. That's how we can get R and W turned on and X turned off. So you can play, for example, if we just want to make it writable but not readable, we would do 2. So let's try that. So we say chmod 200 text dot that. So now if we look at it, sure enough, it's only writable. Okay, we probably actually want to do it like 600. It's probably 600 is a good safe one. That means the user can actually read it. But actually, it's a painful, and I'm curious. We're just going to do that. And now if I want to do more test dot, let's see what it says. See, permission denied, cannot read it. But can I VI? Let me edit it. Yes. Hello. Oh, that's interesting. So I'm user Kelly. Okay, well, technically that should let me write, but not read it. So cat, let me just try to cat, boo, boo, moo, into test. Cat echo hello world. Look at that. But now if I do more test, I cannot see it. So I could write into it, and if I do test.txt, you can see that it has 12 bytes inside of it, so it's not empty, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and the new line 12. So this is a 12-line string that got put into the file, but I cannot see it. So now I have to chmod 600 test, and now if I look at more, now I can see that sure enough I was able to write inside of it, but I was not able to read it. So it does actually work, but VI is more complicated, so that's why it doesn't work. Okay, so here's how, if you wanted to make 764, here's how the combination would work for all the 3 triplets all at the same time. All right, hopefully that helps understand the file permissions. Remember the triplets, what you can do with the file, and who, the user and the group. That's it. That is lesson number 7, and I think I had way too much fun with that one. All right, enjoy.